In this video, I'll be looking at a Web Sketchpad lesson in which students use the distance definitions of an ellipse, a hyperbola, and a parabola to plot points that sit on those conic sections. So here on page 1, our goal is to find locations for point P for which the sum of the distances from P to 2 points, F1 and F2, is a constant. So let's see how we can do that. We need to know the distances from P to F1 and F2. I'll tap the segment tool. That gives me a preview of a segment. And I'll tap to attach this glowing endpoint to F1 and the other endpoint that's now glowing to P. I'll now do the same to construct my segment from P to F2. And now I want to measure the distance from P to F1 and P to F2. I'll use the length tool. Notice now that the entire segment is glowing. I will match this glowing segment to this segment, PF1, and that gives me its length, 4.2 centimeters. I'll do that again. And here I have the length of PF2. Now I'd like to add those together. I'll use the calculate tool. I'll tap here inside this glowing box to open the calculator. I'd like to add these two together. I'm not going to type the actual numbers into the calculation because I'd like this calculation to be dynamic and update when I drag point P. So I'll click directly on this measurement to enter it into the calculation. And then I'll add to that PF2 and tap OK. Here I have the sum of those two lengths. And as I drag P, notice that the measurements are all updated. So now it's up to me to pick a constant. What do I want this constant sum of PF1 plus PF2 to be? Maybe I'll pick 12 centimeters. So I'd like to leave a trace behind of all locations of point P for which that sum is 12. So I'll press leave a trace. And when I drag P, notice it left a trace behind. I'll find another location for P that gives a constant sum of 12 and leave another trace. And I will keep doing this. And if we keep going, we can begin to see the outline of an ellipse with foci at F1 and F2. And this is the very definition of an ellipse, the set of points P, such that the sum of the distances from P to 2 points, the foci, F1 and F2, is constant. Now, once I've done this for one particular constant sum of 12, I can pick a different constant sum, maybe 14. And before I start tracing those points to differentiate them from my first set of points, I can drag this point down here and change the color of the trace. So now when I leave a trace behind, it's red. I'll now go to page 2 using the page navigation here at the bottom. Here we have two sets of concentric circles whose radii increase by 1s. And we're told that point A sits on an ellipse with foci at F1 and F2. Plot other points that sit on the same ellipse. So how can we use these circles to help us? Well, how many circles away from F1 is point A? It's 1, 2, 3, 4, 5 circles. How about A from F2? What's that distance in circles, in units? 1, 2, 3, 4, 5. That's also 5. So A is a total of 10 units away in distance from F1 plus F2. AF1 plus AF2 is 10. So I want to find more points that have a constant sum of 10 when I add their distances from F1 and F2 together. So I could, for example, look for a point that's 4 away from F1, so that would place it on this circle, and it would have to be 6 away from F2, which looks like it's right here. So I'll let go. There's another point. I could also look for 3 away from F1, 3 circles, and 7 from F2. That looks like it would be here. 1, 2, 3, 4, 5, 6, 7. So I can keep finding points that are a sum of 10 away in total from F1 and F2. And these circles allow me to be quite precise without having to take any measurements. So again, we'll get an ellipse, and if you construct an ellipse with Sketchpad or Web Sketchpad using the 2 pins and string technique, which you'll also find on my blog, Sign of the Times, you'll see that this approach of starting with these 2 sets of concentric circles nicely sets things up for the 2 pins and string. In the blog post that accompanies this web sketch, I have a link to the 2 pins and string construction. So page 3 and 4 are very much like 1 and 2, except now we're looking for places where the difference of the distances is 2 centimeters, and then the difference is -2 centimeters. This will construct for us a different conic section. And we again move from looking at distances by measuring lengths to using the circles to help us determine points that satisfy the distance definition of a hyperbola. Same deal on page 5 and 6. This time we're looking at parabolas, but now it's a little different because now we have a focus and a directrix, which is a line. So if we're looking for points such that the distance from the focus to point P is the same as the distance from P to the directrix, rather than take measurements, we can use the circle to find such points. It's a very lovely approach to doing this with no calculation. And then on this page, instead of 2 sets of concentric circles, we have this pattern of concentric circles with lines. And these will allow us to find points that sit on a parabola whose vertex is A and whose directrix is line 1. Once you've found those points, you can look for other points that have a focus at point A and a directrix at either lines 2, 3, or 4. So that's a summary of this lesson of plotting points that satisfy the distance definitions of ellipses, hyperbolas, and parabolas.